So we're starting chapter 20, which is on carboxylic acids. And first thing we're going to do is a little introduction, which is in 21. And then we are going to do some nomenclature in 22, and we'll just go ahead and combine those two sections into one. As far as the introduction goes, there's not a whole lot to say about the carboxylic acids. The carboxyl functional group, as you know, looks like this. So carboxylic acids have an alkyl group attached over here to this carbon. It can be cyclic or straight chain or aromatic. Take a shape like that. Or you could have a hydrogen on the carbon, the smallest carboxylic acid. So both of these are examples of carboxylic acids. All carboxylic acids are weak acids. You learned in Gen Chem that there are only 6 strong acids, and none of them are carboxylic acids. Weak acid, if you recall from Gen Chem, that just simply means that when you put the acid, the carboxylic acid in this case, in water, it exists in equilibrium with its conjugate base and hydronium ion. And the conjugate base of a carboxylic acid is carboxylate anion. We're going to learn a little bit about them and how to name them later on in the chapter. We're not going to do it as part of the nomenclature in section 22, but we will get to it. So all carboxylic acids are weak acids. They all have equilibrium with water. As far as nomenclature goes, one of the things that makes naming carboxylic acids really simple is that the carboxyl group is the highest priority functional group. And because it's the highest priority functional group, this means that if you have a carboxyl group present on a molecule, you have no choice but to name the molecule as a carboxylic acid, which means that we don't need to learn how to name carboxyl functional groups as substituents on some other kind of molecule. It's always going to dictate the name of the molecule overall. There are 3 common carboxylic acids that you should be familiar with their common names. One of them, the littlest carboxylic acid, it goes by formic acid. The next smallest one with 2 carbons, this would be one that you probably recall from Gen Chem because we use it a lot in Gen Chem. This is acetic acid. And then one that you learned last quarter in the aromatic chapters, benzoic acid. For the rest of the carboxylic acids, they're typically just referred to by their IUPAC name, so we're going to learn the IUPAC system for naming all of the rest of them. In the IUPAC system, as usual, we're going to identify the longest carbon chain that contains the carboxyl group. the carbon of the carboxyl group is always carbon number 1. And this can actually be really easy to forget because we're so used to your mind is going to be so trained to looking at this whole entire functional group as a functional group attached to the carbon chain that it's kind of, at this point, counterintuitive to include it in the carbon chain. So it can be really easy to look at, for example, acetic acid and say this is a 1 carbon chain molecule because you're counting this as a functional group that's attached to that chain. But in fact, this carbon is included in the carbon chain, and it's always by default carbon number 1. So don't leave that carbon out. Practice it. Don't leave it out of the numbering. And the IUPAC name for the carboxylic acid is going to be an alkanoic acid. Based on the number of carbons in the chain, it's going to be a pentanoic acid or a hexanoic acid or a butanoic acid or buteenoic acid if there's a double bond. Or if it's cyclic, cycloalkane carboxylic acid. Cycloalkane carboxylic is one word, acid is the second, so that would be, for example, cyclohexane carboxylic acid or cyclopentene carboxylic acid. Let's do a few examples of naming. For a straight chain, again, we want to find the longest carbon chain that includes the carboxyl group, which means we don't want to count like this. We've got to include this in the carbon chain. Longest carbon chain is there. Don't forget that the carboxyl carbon is carbon number 1, so this is going to be numbered from right to left. 5 carbons. 5 carbon is pentane, so this is going to be a pentanoic acid. Notice that E is dropped. Pentanoic acid with an iodo on number 2 and a methyl on number 3. I comes before M, so iodo comes first in the name. 2 iodo, 3 methyl, pentanoic acid. You don't need to say that the carboxylic acid group is on carbon number 1 because that's where it has to be. Just like with a cyclic molecule, and the functional group that we put on carbon number 1, that's just implied. And you don't need to identify it as being on carbon number 1. Same thing in this case.